So can you, Amanda, can you read our today's title of the notes?
Natural logarithm.
Yes, natural logarithm. So natural logarithms are base E. Okay. On last week, we did a worksheet called E, and you were able to find values, right? As n, the value of n changes from small to big, and the bigger the value of n, the answer you got was closer and closer to what? Guess what? It was closer and closer to? Not 0. What was it on? It's over 2. Not infinity, because that's way too big. E, because the bigger the number you punch in for n, and remember this value, that way I said do not round. Remember this value? Did the value ever end? No. Did it ever repeat? No. So if a number that does not end and it does not repeat, it's called what kind of number? An irrational number. Okay. So E is an irrational number. Now in log, when we have log base E, it is called a natural log. Okay. So again, if you have log base E, it is called a natural log. And the format for your exponential, base E to a power of y equals x, if and only if I could rewrite it in log form. Log base E of x equals to y. That has to be true. Now, because log base E is so important in mathematics and science worlds, that immediately we change it and call ln of x equals y. Okay? So if you ever see log base E, you have to rewrite it in what? What do we have to rewrite ln of x? I mean, no, I just gave you the answer. What do we have to rewrite log base E as? ln, right? Because it's that common, it's that important that it has its own name. Okay, so and guess what? Because it's still log, all the rules of logs are still exactly the same. The only new thing you're learning today is the value of what? E. Okay, now let me ask you this. If I said give me a value for pi, you said what? 3.14. You knew it. I want you to memorize E. 2.718. Let's, right? Or 2.72 if you're going to do it that way. So E is 2.718. I want you to say it like 10 times in your head.
2.718.
Yeah. Because when you guys are doing this, I want you to be just as quick as pi. Because all of you know pi. Now I want all of you to know E just as well. So E is 2.718, right? Or 2.712, depends on how you want to memorize that. Okay. Okay. Examples 1, 2, 3, and 4. Use your calculator. That means that's why I asked you to go find one. Can you find the button natural log on your calculator? Where is it at? Does it have its own button? Yes. Punch it in. Hit natural log. And then 4.76. Round to 2 decimal places. Okay. Once you have an answer, write it on your notes. We're doing examples 1, 2, 3, 4. So example 1, find the button. Okay. So I want you to find the button, natural log. Is it already on your calculator? If it is, find it, punch it in. Okay. And then 4.76, once you have your own answer in your calculator, turn to a partner and compare your answers, and then write it in your notes. And then I'm shuffling your cards. 2 decimal places. Ainsley? No, it doesn't equal anything. You're just using a calculator. We're practicing how to find it on your calculator. Okay? It's gonna give you decimals because it's an irrational. So Roger, what did your calculator say? 2 decimal places.
I have no idea.
Find it.
Yeah.
You have to know how to use your calculator, hon. Find ln somewhere. You have your own calculator. You got to know how to use it. Because that's not going to do you any good. Find ln. Is it subscript somewhere? You see that you have log right here. You don't have that line. Okay, so in the future, just bottom one line. Okay. That means, Roger, come on down and get this calculator as well for the next couple of examples. Anyone else who does not have that button on your calculator? You need to borrow one of mine. Okay. So Roger's gonna locate that. Emma H, can you give me 2 decimal places, please?
1.56.
Someone confirm that for me since, okay, perfect. Do 2, everyone do 2, 3 and 4. But 3 and 4 are slightly different, okay? Once you have the answer to 2, Emma P, whenever you're ready for 2. Someone confirm that? Perfect. Now E, do you know where your E button is on your calculator? It's second natural log. So punch it in. Now once you hit E, a parentheses, 1, it's already open. That means you have to go close it on the other side, okay? Punch in your 3 and 4. Get both answers, write it in your notes. Lena, whenever you're ready, give me the answer to 3. 2.564. Just 2 decimal places to keep it consistent. What did you get? 57. Someone confirm? Okay. 4, can you, Carly, give me the answer to 4.
I got 12,332.58.
12,332?
0.58.
0.58. Yes? Okay, thank you. So those questions are just make sure you know how to locate those buttons, okay? Example 5 and 6, evaluate each expression. Evaluate means what, y'all?
Solve.
Solve. Give me one final answer. Okay. And does it matter if you use a variable or not? No. There's no variable in here, so you can make up your own variable. So what variable would you like to use today? Y, X. You don't have to. I'm going to use a blank box. Right? I don't have to use a variable. I'm just going to use that blank box if you don't like variable. So, question is, how do you get an answer from natural log without a calculator? Natural log of E natural log of E to the 5th power. What would you do?
Change LE back to log.
Yes, to understand this better, natural log class is the same exact thing as log base what? E, okay, log base E of E to the 5th power equals something. We don't know that something. I'm going to give myself a box. Remember, you have evaluated logs before. What did you do from here? Yes, change it to exponential. What's your base? E. So E to the what? E to the box, right? Or Y, whatever you use in your notes. I have a box. E to some box equals to what? E to the 5th. Whoa, you are in exponential form. Your bases are identical. Can I drop my bases?
Yes.
That means my final answer is what? 5. Final answer, class, is 5. Okay. Ainsley, question?
If I got that answer in the first place, do I have to do all that?
If you can get it without a calculator, yes. Okay. Now, let me ask you this. Ainsley said, well, I can do that in my head.
No, I was like, I did it without doing, I just did it from the first equation. Is there?
Oh, yeah, I'm just showing you all the steps.
Oh.
But yes. Now, however much you want to write in your notes is really a personal choice, okay? Actually, you can do this all in your head. Okay. Now that we did, look at that. We wrote all the steps out. Would you agree? I wrote all the steps out for all of us. And the answer is what? 5. Couldn't you look at it and know what the answer is right away? If I give you this from now on, natural log base E of 900. What's the answer? How do you know? I want you to do this for me in your calculator. Punch in natural log of e. Just natural log of e. What does the calculator say? 1. Yes, it does say 1 because natural log, by the way, it's just log base e. What does the rule say? What does the log property say of an exponent of 900? How would you rewrite that? If you have an exponent in log, what does it become? What does it become? What does the properties of log say for an exponent? Where does it go? It goes to the front. It becomes a leading coefficient. So this is really technically like this, right, class? You guys just discover ln of e is always what? 1. So 900 times 1, it's always 900. So from now on, if you see ln of e, do you need to do any work? No, you know the answer. But it doesn't just have to be natural log. Let me come up with something else. Log base 5 of 5 to the 7th. Someone give me the answer without any calculator. 7. How do you know? Because it's power 7 becomes a multiplication class. Log base 5 of 5, it's always 1. How come? How come that's always 1? What does a change of base say? If you said, okay, I'm going to use my change of base, what would you do in change of base? Log 5 divided by log, that is obviously 1. So if you see something like this, do you need to do any work? No. Well, could you if you don't remember? Yes. Okay, you have the tools to do either one. Okay. Now let's do number 6. Number 6 says evaluate still. E to the power of natural log of 17. So tell me, is this one right here currently in exponential form or log form? Exponential. I don't know the answer. I'm going to give myself a box. How do you solve exponential? Yep, drop it down, put in log. What's your base? Log base e of natural log of, of my box, my bad. Log base e of my box equal to natural log of 17. You may not keep log base e. If you see it, immediately have to change it to what? ln. So right now, change that to ln of my box. ln of my box equals ln of. So do you know what the answer is? The answer is 17. Okay, and we just did all of the work for that. Now tell me, what do you think e to the ln is? What do you think that is? Can you see there's a pattern of this? E to the ln of 1. Use your calculator. Do it right now. What's e to the ln of 1? It's 1. 1 times 17 is? 1 times 17 is? 17. So from now on, you can do all the work to get 17, or if you know it, can you just write the answer? All right. Let me ask you this one question here. If I gave you 5 to the log base 5 of 99, what's your answer? 99. How come? Yes, 5 raised to the power of log base 5, technically, of 1. It's always what, guess? Always what? 1. 1 times 99 is? 99. Okay, so if you can see it and you can do it, get the answer. If you can't, you can do the math and work it out either way. All right, 7 all the way to 10. Solve. On 7, what are we solving for? X. In this one, they do have a variable, so you do have to give me x equals, okay? E to the power of 3x equals 12. How do you solve for that? Yes, what's your base? E. So log base E of what? 12 equals to what? Good. I see log base E. What do I do? Yes. ln of 12 equals 3x. All right, punch it in, James. What's ln of 12, 2 decimal places? 2.48 equals 3x. What do you do next over here, Kai? Good. Kai, 2.48 divided by 3, Kai. Round to 2 decimal places, hon. X is what? So 0.8266 or 0.83? Someone confirm that for me? Confirm. All right. Perfect. As you can see, the properties of logs are exactly the same because this is still log. It's just, you're just learning a new number called E. 8, solve. What are we solving for, Joe, on number 8? Good. What do you do first? Not yet. Yes, you have to isolate your base, okay? So divide both sides by 4. Brandon N, 64 divided by 4 is? Perfect. I got e to the power of x minus 1 equals 16. Chance, what do you want to do next?
Rewrite it down.
Rewrite it in what form, hon? That's right. Log, what is the base? E, perfect. Of what? Good, equals, that's right. I cannot keep log base E, y'all. What does that become? ln of 16 equals x minus 1. All right, punch it in. ln of 16 is what, AJ? 2 decimal places. 2.77 equal to x minus 1. Last step. So, Gemma, what is x?
3.77.
Thank you. Not too bad, right? We have 9 and 10 in solving, and then we have 2 graphing questions. 9, solve still. What are we solving for on 9? X. How do we solve on 9? Make it 1 log. You are right. In log properties, when you have addition of log, how do you condense it? Multiplication is 4 times x plus 1 equals 2. Can I distribute the 4x plus 1? Yes. ln of 4x plus what? 4 equals 2. I have 1 log on the left. No logs at all on the right. Can I drop my left log? No. What do you do? Can't drop the log. Divide both sides by ln. Would you agree with Hannah? It's ln by itself means anything. Does it mean anything if you divide both sides by just ln? ln by itself, does it mean anything at all? I want you to hit your calculator. Just hit ln and nothing behind it. Just hit ln, hit enter. Yeah. Guys, ln by itself, it's just an organic piece of wood. Natural log. It has no math value. So, can I divide both sides by ln? No. So now what? I can't solve in log form. I wish I have an equivalency form. Exponential. What is the base? E. You're right. E to the what? E to the 2 is perfect. Equals 4x plus 4. All right, punch it in your calculator. E to the 2nd power, Arista, 2 decimal places. What do you think it says?
7.39.
Okay, and then solve it normally. Subtract 4 from both sides. So 7.39, I'm sorry, not minus 4. I just wrote that wrong. Minus 4. So Miss Victoria, what's 7.39 minus 4? 3.39 equals 4x. Divide both sides by 4. Okay. So x is about, what do you think you come up with, Dylan? 0.85. Now check your answer. When I plug that back into my original equation, is that going to give me a negative log value anytime?
No.
No, so I can keep it. Very good. 10, very similarly, we are going to solve. What are we solving for this one? X. What do you do first? You're going to condense them. But how? You do. But before I can even multiply, I have to do something else before I can multiply. Get rid of the 2 and 3 by doing how? I need to do something with those coefficients. That's exactly right. How do I have to change it back to exponential. I mean, not exponential, exponents of log. So natural log right now is 2 times natural log of x. I would have to rewrite it as natural log of x to what power? Just get a second. Plus natural log of 2 to what power? 3 equals to 5. I can't do anything with x squared right now, so I'm going to copy that down. But 2 to the 3rd is what, McKenna? Good. So natural log of 8 equals 5. Okay, similarly to number 9, I have 2 logs on the left, but no logs on the right. What do you do next? Multiply. Natural log of x squared times 8. By the way, x squared times 8 is exactly 8x squared equals 5. Now I have 1 log on the left, no logs on the right. Can I drop it? No. I have to do what? Rewrite it in what form? E to the what? E to the 5th. Very good. Equals 8x squared. Now when you're ready, Grace, e to the 5th is what in 2 decimal places? Okay, so 148.41, Grace, you said? Thank you. Someone confirm that for me? Equals 8x squared. Divide both sides by 8. So take that, divide by 8. What is that? Brendan C., when you're ready, 2 decimal places. Six, 2 decimal, 6.5? 55, thank you. How do you solve x from here? Square root. Make sure you have 2 answers, right? Okay, so take a square root plus or minus what? 4.31 you said? Thank you. Can I keep both answers, by the way? How come? Right, when I check them, I can't keep both. Remember, you have to make sure eliminate a value that will make your log negative. So only keep the positive. Yes, Brennan C.
Why isn't that go to be 18.6?
I'm sorry, one more time?
Why can't I make that 18.6?
18.6, because I have been asking for 2 decimal places just to keep it consistent with the rest of the notes. Okay. All right, graphing. Class, graphing is the same thing. All of transformations are the same, except now you're just learning a new number. Called what? What's a new number called? E, right? 2.718. Okay. Graph each function, then find all the stuff that we normally find. So we're going to make a table, x and y. We will pick -2, -1, 0, 1, and 2. Similarly, we're going to plug in e. E to the -2 is exactly the same thing as 1 over e squared. True or false? True. Now use your calculator. 1 divided by e squared is what? 2 decimal places, okay? So punch it in. Get it ready. So Brooke, whenever you're ready, give me 2 decimal places, hon. 0.14. Someone confirm that for me? Thank you. E to the negative 1 is the same thing as 1 over E. Someone punch that in. 1 divided by E is what? Daniel, whenever you're ready. One divided by E? If it's not allowing you to do 1 divided by E, Daniel, make sure you punch in 1 divided by E to the 1 power. Because sometimes some of them just come up with 1 power right away. Thank you. Next one, E to the 0. Class is always 1. E to the 1, y'all. Guys, memorize the number E right now. 2.718. E to the 2nd, round it out. What is that one? 7.39. Perfect. This is an exponential. You need an asymptote. Which one? Is it x can never ever be 0 or y can never ever be 0 for exponential? Y can never ever be 0. So I will have an asymptote this way. Let me get a different color. There you go. Okay. Let's plot it in. Ready to go? Negative 2, super close to the asymptote. Negative 1, still super close. 0 is now 1. 1 is about 2 and some change. And 2 is going to be 2 and some 7 and some change. 2, 4, 6, 7, 7 and some change. Okay. Is the shape the same as all the exponentials that you've studied so far? There's no difference. All right, let's answer the, bless you, H and K. What's your H and K? 0, 0, right? There's no transformation, there's no movement. X-intercept, do you have any? Any x-intercept? No, you guys, you have an asymptote right there. Y-intercept, any? 0, 1. What's your domain for all exponential functions? All reals. What's the range for this exponential function? 0 to infinity. Can I write y is bigger than 0? Yeah. Is this an increasing or decreasing function? Increasing from where to where? Negative infinity to positive infinity. Do we have a horizontal or vertical asymptote? Horizontal, so that means that vertical is none. Horizontal asymptote is where? At x or y? Y equals 0. All right, one more. Again, we have already graphed log a bunch of times, except this time we're just graphing log base what? Base natural log, which is log base E, okay? Remember, when we graph log, we write an equivalency equation. What's an equivalency equation of that? Whoa, it's bubbling. Can you help me on that one? Thank you. So y equals natural log of x, which is y equals log base E of x. What's the equivalent equation of natural log of x? What do we use when we graph log? Exponential. What would that look like? That's right. So for this one, do we pick y or do we pick x? We pick y. Well, if I pick y, look at my 11 and 12 example. I just switch. In 11, I pick x. In 12, I pick y, and the y values are exactly the? Didn't we just switch x and y here? If I switch x and y, what are these two functions called? Not reciprocal, but start with an I. Inverses. What? Okay, these two functions, y'all, are inverses of each other. That means all the x and y's are now swapped, okay? Do I need to do any work at all now to get the x values? No, because I can just look at the table above. So this one It's e to the negative 2, which we already calculated the value. That was about 0.14. This one was e to the negative 1, which is about 0.37. This one, e to the 0, it's always 1. E to the 1, it's always e, which is, you should know, what's the value? That's right, 2.718. E squared, we already punched it in earlier. It's about 7.39. Because these two are inverses of each other, y'all. Where is your asymptote now? Still horizontal, or is it now vertical? It is vertical, right? Because remember, we're switching x and y and y for x. Vertical asymptote goes like this. Plot in your dots. 0.14, go to negative 2. 0.37, go to negative 1. 1, saying it's 0. 2.718, go up to 1. 7.392467, and some change. 2467. And go up to about 2. So okay, we have a function. H and K, what is it? 0, 0, x intercept? 1, 0, y intercept? None. Domain? 0 to infinity. Range? All reals. Increase or decrease? Still increase. Very good. From where to where? Increase from where to where? No, remember, increase and decrease, we use x interval. From 0 all the way to infinity. Horizontal, vertical asymptote? Vertical, so I'm going to write NA on horizontal. Vertical is where? X equal to 0. Now notice how I'm not lecturing anything on the transformation, but you could still do them, right? Because there are no difference at all. That's an egg roll for today.